Okay, so today we are working on valid parentheses. This is day number 16 of the Blind 75. And yeah, like I literally just mentioned, this is a stack solution. We'll talk about that a little bit here. So let's take a look at the problem first. We'll do a little bit of diagramming. We'll talk a little bit about how stacks work with this problem, and then we'll code up a solution. Okay, so valid parentheses, you are given a string S consisting of the following characters, and then we have a bunch of pairs of opening parentheses with closing parentheses. So just normal ones. We've got curly braces. We've got square brackets. So yeah, all the left side ones we would call opening. All of the right side ones we would call closing. And they give us some rules here. They say the input string S is valid if and only if. Okay, so some criteria here. Every open bracket is closed by the same type of closed bracket. So if you have a left parenthesis, you need to close it with a right parenthesis. If you have a left curly brace, you have to close it with a right curly brace, and so on. And then open brackets have to be closed in the correct order. So that means something like this. Ooh, hello. If we put that there, and then if we put this here, this actually doesn't work because this pairs up some mismatched types, right? So we kind of need the layers to work out here in such a way that every time you hit a closing bracket, the last thing you saw has to have been the same type of opening bracket. Okay, and then finally every close bracket has a corresponding open bracket of the same type. Okay, and so what this means is you can't have, well, actually a pretty straightforward example would be you can't have something like this. So we can't have just a bunch of closing brackets that don't get paired up with opening brackets. This is the reverse part of this, like you have to have each opening bracket closed by the right type of closed bracket. That's actually captured in this, so not only does it need to be closed, but it needs to be closed by the correct type of bracket. All right, so 3 rules. These are basically just describing the rules of how parentheses work that we kind of all know, so no huge deal on that. Okay, and then finally we will return true if S is a valid string and false otherwise. So normal parentheses rules here. We need to kind of work layer by layer to figure out if the parentheses are all paired up correctly. And assuming they were, we'll return true, and if anything went wrong in that process, we'll return false. So first one, very straightforward. Opening square bracket, closing square bracket. We return true because that is a valid set of parentheses. Same with this one. If you go layer by layer, we've got a pair of curly braces, a pair of square brackets, and then a pair of parentheses. They all match up properly. There's nothing left over, so we return true. This is pretty much the example I used, actually, but in this one, notice that when we get, well, there's a couple ways to phrase this, but when we get here, we're attempting to close a square bracket before we close a regular parenthesis here. That's problematic because, again, we have to, according to number 2, close these brackets in the correct order. Okay, the only other constraint we're given, the length of S will be between 1 and 1,000, and then at the beginning they told us we're only going to use these characters, and that's that. So, yeah, there's actually not much to explain here. Normally I feel like there's more to clarify, but it's a pretty straightforward problem. So let's do a little diagramming and talk about how we can solve this guy. So we'll do both a valid and an invalid example here. And if you think about what's going on here, so here's the valid example, or one of the valid examples they gave us. If this is our string S, what we need to track basically is like what's the most recent opening bracket that we saw, right? Now when we do this kind of character by character here, anytime we see an opening bracket, we'll kind of list it, right? So something like this, we'll shift over, and then we see this opening bracket, and then we see this opening bracket, and if we literally just write this down like we would by hand, you'll see that basically the thing we're interested in at any given moment is like, what's the most recent one? In other words, which one is kind of the end of the list here, right? And then when we hit a closing bracket of any sort, what we need to check is, was the last thing we saw the correct type of closing bracket, right? Or, sorry, was it the correct type of opening bracket? So in this case, for example, and we just know this because we know how parentheses work, but we'll talk about how to do this programmatically in a sec. We see this closing curly brace, and we ask, hey, was the most recent thing that we saw an opening curly brace? And if so, basically we say, okay, this guy is accounted for, we don't need to track it anymore. I'm going to just erase it, and we'll talk about how to do that in code in a sec. We keep going. In this case, we see another closing brace. And again, we ask ourselves, hey, does this closing brace match the most recent type of opening brace that we saw? And we say, yes, it sure does. And in this case, again, that means that we no longer need to worry about this. It's been closed properly. And as you can see, we keep going one more time, and we've worked through all of the layers from inside to outside. This time the closing parenthesis matches the opening parenthesis, and we're good to go. Now that we're at the end of the list, and there's nothing left over, this means we successfully closed all of the opening brackets, and that's a win for us. So let's try and break it now. So that's a very clear, valid example. Let's say we had an opening brace over here. If that's the case, we would have put it on at the beginning. We would have put on all the rest of these, closed all the rest of these, and this guy still would have been left at the end in our list, right? And that's going to tell us, hey, that means that we didn't successfully close all of the opening brackets. This means it's not actually a valid set of parentheses, and we'll return false at that point. So by the time we get to the end of the string, if there's anything left over, we'll return false. Okay, and let's try and break this in a different way now. Let's say we did this and we had, well, let's just put it over here this time. Let's say we had a curly brace right here. If this was the case, we would put on, and I'm going to skip the pointer movement here because we're just going one by one. We would put on a round parenthesis, a curly brace, a square bracket, a curly brace, and then we would get to this guy right here. We would pop this guy off. We get to this guy right here. Pop this guy off. And then when we get to this point, we would again ask ourselves, hey, was the most recent opening brace that we saw, did it match with the closing brace that we're seeing right now? And the answer is no. So at this point, we can return false immediately because there's going to be an out of order parenthesization. In this case, there's also like an extra thing there, but in this case, the thing that tips us off to the fact that we can return false is that this closing brace does not match with the most recent opening brace we saw. Okay, one last failure condition, so let's just talk about all of them. If we had something like, well, I guess something like this actually works. If we just get rid of this opening brace here, then we would see the list look like this. We would have a square bracket. Ooh, let me erase that. We would have a square bracket, an opening curly brace, and then we would see the closing curly brace. We would see the closing square bracket, and finally we would get to this end parenthesis, and there's nothing in the list right now, right? So the final scenario we can hit is if we have a closing brace and there was never anything opened, that's also a failure condition, right? Okay, and assuming that none of the things that can go wrong do go wrong, we get all the way to the end of the list and it's empty when we're done, or we get all the way to the end of the string and the list is empty when we're done, that means we've got a valid parenthesis and we can return true. So basically we'll just go all the way through the string and say, if anything goes wrong, return false, but if you get all the way to the end and that list is empty, return true. Now, I've been kind of avoiding saying the word stack as we go here, and that's because stacks effectively are just lists. Actually, I don't know if we've discussed this in great detail, so I might as well talk about it now while we got a little bit of time. A stack is what we sometimes call an abstract data structure. Actually, sorry. I was like, I think it's abbreviated ADT. This is short for abstract data type. And all that means is the stack just needs to be able to do certain things. It doesn't really matter what you use to make it happen. It just needs to have certain qualities or certain capabilities. And stacks specifically, if you've learned about them before, all they really need is for the last thing in to be the first thing out. And we sometimes abbreviate this LIFO, last in, first out. And this is great for Python lists because, as we've talked about before, when you've got a list in Python, it doesn't really matter what is in the list, but it is quite efficient to add and remove from the back, but really tough or really slow to add or remove from the front. So the nature of lists in Python's kind of immediately makes them stacks, as long as you only deal with whatever is on the end of the list. So some operations that will be relevant for stacks here are going to be things like, I'll just say like array at index -1. This says get the last thing in the list, right? There's actually some special functions like pop and append that only deal with the back of the list. So pop is going to be remove the thing on the back, append is going to be add something to the back. And again, for Python lists, it's really quick to do this. It's constant time complexity, and that's one of the things that is a requirement for a stack. Okay, and so how is that related to this problem? Well, like we kept saying as we were working through this, we are always interested in the most recent thing that got added, right? So in this case, as we go through the open brackets here, we're always interested in whatever the last thing to be considered was. Once we're done with that, we get rid of it, and that's exactly what a stack is. So we always put things onto the end, and we always take things off of the end. And that's what makes this a stack problem. Okay, so just to summarize here, we'll go through all of the characters in this string. Okay, and here's kind of the overall, like in layman's terms, algorithm here. I have no idea what I just said. I just talked so fast. Here's the overall algorithm in layman's terms. If we're looking at an opening brace, then we'll go ahead and add to the stack. Okay? On the other hand, if it's a closing brace and we were guaranteed that it'll only be opening and closing braces, then there's a few things we need to consider. If it's an empty stack, that means it never got opened, so we're trying to close something that was never opened. In that case, we fail. We immediately return false. Okay, similarly, if it's the wrong opening brace, that's another failure condition, because we're trying to close something in the wrong order. Okay, and then those are the two ways we can fail, assuming we don't fail in either of those ways. So I'll say if valid. Well, I'll even just say, so here's our two failure conditions, and otherwise, what we're going to do is remove the top of the stack. Great, and I'm saying that word top. Hello, welcome in. I'm saying that word top of stack. You'll notice I've been writing the list left to right just because that's how we tend to represent list data. If you haven't worked with stacks before, the reason we call them stacks is because when you stack things in real life, the most recent thing to be stacked is on top, right? So that's what I mean by top of stack, is the most recent thing. And then when we do something like pop, it's removing from the top, right? And so on and so forth. So yeah, pretty straightforward here. Yeah, we'll get to the code, and we're making great time. Okay, so I'll go ahead and say here, because we know we're going to need a stack. So I did like kind of hand wave a couple of the things that we'll have to do here, namely figuring out if something is an opening or a closing brace, and then figuring out what the matching brace is. It turns out we have a data type that is great for this that we've talked about before, actually. And that data type is a dictionary or a map. We've historically used these to like keep counts of things or to prevent duplicates of things. But another use of them is just to figure out what pairs up with what, so to speak. That's why we call them dictionaries sometimes. Or in math terms, what maps to what, and that's another reason why we call them maps. Anyway, so we'll use a map or a dictionary here, and here's how we'll define it, because we want to figure out if stuff is opening or closing, and then we also want to figure out if we're looking at a closing brace, what's the opening brace that pairs up with it. So I'll say close to open is going to be this dictionary here. And we'll just literally list out, because there's only a few of them. Hey, closing parenthesis goes with opening parenthesis. Closing curly brace goes with opening curly brace. And closing square bracket goes with opening square bracket. Okay, and I have put these in this specific order because if it's... Yeah, well, in short, if it's not a closing brace, we don't need to know what it pairs up with, right? We just throw it on the stack. On the other hand, if it is a closing brace, we need to make sure that it actually matched up properly. So it makes sense for us to do closing as keys and opening as values, because we need to search through the keys pretty often. And then we only need to know about the matching if we're looking at a closing brace. Okay, so from here, I'll say I'll just say character in S. Okay, and now we need to capture our like success and failure conditions. Let me split view this so that we can actually look at them as we go. Okay, so I said if it's an opening brace, just do this, which is actually kind of valid. But there's a couple ways we could phrase this. So we could say if the character is not in close to open. Okay, so if it's not one of these guys, then we know it has to be one of these guys. So assuming we're looking at an opening bracket, then just go ahead and put it onto the stack. And our syntax for that is going to be stack.append that character. Okay, so otherwise, so I'll say this is for opening brackets, and then the else is for closing brackets. Okay, and in the else condition, we say, okay, if it hits one of these failure conditions, just return false. So if there's nothing in the stack, return false. On the other hand, if we have the wrong type of bracket that opened it, so if the most recent bracket we looked at, the most recent opening bracket we looked at, is not the right one, and so we can say if it's not the mapped value for this closing bracket, return false. Okay, so let's dissect that just a little bit more here. Oh, hello. It really doesn't want to move that over. Great. Okay, so we know if we're in this chunk that we're looking at a closing bracket. So if it was never opened and we're trying to close it, that's a failure condition. If we don't have the corresponding open bracket, that's a failure condition. Okay, and then finally, if we didn't hit those two failure conditions, then we can just remove the top of the stack, and our syntax for this is just stack.pop. Okay, and there's quite a few ways that we can get through the logic of this. This is just the way that we had it written in the algorithm, and it's actually kind of nice. There's not too much indentation here. You can get quite a few layers deep if you're not careful on this problem, which we haven't really talked about that, but yeah, too much indentation is a pain in the butt, so we want to avoid that when we can. Okay, so assuming we get through the entire string, everything pairs up properly. Remember, there's still one last condition that we have to be aware of, and I don't remember if I even put it on here. But when we're done, it's possible that we opened some braces and they were never closed. Okay, so if there's still stuff in the stack, that means we failed, right? Here's how I'm going to put it. I'm going to say return whether the length of the stack is 0. So if it is 0, that means we successfully closed everything. We can return true, which is what this evaluates to if it's empty, right? And then if there is still stuff in the stack, then this will not be true, right? There will be some elements, and the length won't equal 0, and that will return false for us automatically. Got 2 closing brackets in your dictionary. Yeah, kind of thought I would at some point. Thank you for catching that. I do be messing this stuff up. Great, and I think that's it. Yeah. Okay, and so yeah, the strength of the stack here, I guess we'll go over this more in a sec, but the strength of the stack here is it always lets us look at the most recent thing that we put on the top of it. So let's run it and see what I messed up, because I always mess something up. Ahaha. Ahaha. I used parentheses instead of square brackets here. Sweet. Okay, the run works. Oh, sorry to hear your head hurts. Is it because of the problem, or is it just generally? Do you have a question on it, if it's about the problem? Oh, okay, valid. Yeah, okay, so yes, the strength of the stack, it always lets us look at whatever the most recent thing was that we added, and then in this case we can track the things that get closed correctly that we don't have to worry about anymore by popping the stack, and this lets us work outward by one layer. So adding onto the stack is, okay, let's move a layer in, a layer in, a layer in, and then once we get some closing braces we can jump out by one layer kind of freely here, which is nice. Okay, and just in terms of time complexity, we look at everything once, basically. So every bracket has just one operation associated with it. Checking the length of the stack at the end is also constant time, so this is just O of n, which is great news for us. Yeah, truthfully, I don't know what the naive solution would look like here. Like, I would probably struggle to make this worse. So it's a good solution. It's probably the solution you'll stumble upon if you're thinking about time complexity. And that's what we got for today. So yeah, we'll wrap it there. This is actually the only stack problem, so I don't really have more to say about it. But if y'all have any questions, let me know. As usual, would love to see your solution in the text thread now that we've gone through it together. And even, if you're going to tackle this on your own, maybe see if you can turn this logic on its head somehow. I did like opening brackets, otherwise closing brackets. Maybe see if you can reverse that and see what changes. Anyways, have a good night, y'all, and I will not see you tomorrow because we'll get back to it on Monday.